Welcome back. In this section, we'll be talking about another way of defining our trigonometric functions. Previously, we'd talked about angles in standard position, and for those, when we were finding the values of our trig functions, we took any point on the terminal side, and then based on the x and y coordinate, and also r, which was the distance from the origin to that point, that's how we defined our trig functions. We're going to do a similar sort of thing here, but we're modifying it so that we're not just taking any point on the terminal side, but what we're doing is putting a unit circle, a circle of radius 1, over top of our angle, and so that the point that we're selecting is a point that's on our unit circle and also on the terminal side. And the reason why this is a nice idea for us is that a unit circle, that's a circle with radius 1, means that whatever the point is, it's a point that is 1 unit away from the origin. Or in other words, if we're thinking about things within the unit circle, r will always be 1, which means our 6 trig functions are a little bit easier to define. Instead of sine being y over r, since r is 1, then sine of theta is just y. And same thing for cos of theta. Instead of x over r, it's x over 1, which is just x. And then, of course, we have our others. Cosecant and secant, the reciprocals of sine and cosine, 1 over y and 1 over x. And two of our functions are the same as before. Tangent and cotangent are both y over x or x over y, whether we're thinking about them in terms of being inside a unit circle or not. Now, the unit circle is especially useful if we're thinking about finding exact values for multiples of 90 degrees. And so here I've got my table for multiples of 90 degrees, and I'm just going to write them in radians while I'm at it. That would be pi over 2, pi, 3 pi over 2, and 2 pi for radians. And now the idea here, if we're thinking about sine of theta would be the y value on our unit circle. And so for 0 degrees, the y value would be 0. And then at 90 degrees, the y value is 1. And then at 180, the y value is 0. At 270, the y value is -1. And back at 360, which is same place as 0 degrees, the y value is 0. And we can do the same sort of thing for cosine. Cosine would be the x value as we go around that unit circle. And so if we're starting at 0 degrees, the x value there would be 1. Then the x value at 90 degrees is 0. At 180 degrees, the x value is -1. At 270 degrees, the x value is 0. And then when we make our way back to 360 degrees, our x value is back to 1 again. For the other 4 trig functions, they're easy enough to find, tangent being y divided by x. And of course, if tangent is y over x, here y is the same thing as sine of theta, and x is the same thing as cos of theta. So that means for tangent, we just have to take the sine value over the cosine value. Tangent of 0 would be 0 divided by 1, which is 0. Tangent of 90 would be 1 divided by 0, which is undefined. And I can do the same thing with the rest. 0 divided by -1 is 0. -1 divided by 0 is undefined. 0 divided by 1 is 0. And cotangent, much in the same way. Cotangent is the reciprocal of tangent, so it should be x over y, which is, of course, the cosine value over the sine value. And so I'll do the same thing for cotangent, thinking about the cosine value divided by the sine value. So starting at 0, we'll have 1 divided by 0, which is undefined. 0 divided by 1, which is 0. -1 divided by 0, undefined. 0 divided by negative 1, which is 0, and 1 divided by 0, which is undefined. And for secant and cosecant, I'm just going to use the fact that they're reciprocals of cosine and sine. So for secant, I'll look at that as the reciprocal of cosine. Secant of 0 is the reciprocal of 1. Secant of 90 is the reciprocal of 0. 1 over 0, that is undefined. Secant of 180, that's the reciprocal of negative 1, which is negative 1. Secant of 270 is the reciprocal of 0, and 1 over 0, that is undefined. And last one, we have secant of 360, that's the reciprocal of 1, which is 1. And now I'll do the same thing for cosecant. It's the reciprocal of sine. So for my cosecant of 0 degrees, that's the reciprocal of 0, which is undefined. Reciprocal of 1 for 90 degrees, which is 1. Reciprocal of 0 for 180 degrees, which is undefined. Reciprocal of negative 1, which is negative 1 for 270 degrees. And the reciprocal of 0, which is undefined for 360 degrees. And there we go. We could also look at a problem much like ones that we've already looked at, both in right triangle trig and for angles in standard position. Here we've got an angle that's in quadrant 3, so we'll draw it in standard position, and we happen to know that the terminal arm is crossing the unit circle at x equals to negative 3/5. So since we're in the unit circle, then that means we're dealing with r being 1. We're going to be then thinking about things in terms of our unit circle definition. And if we're remembering that on the unit circle, the definition for the unit circle was, or the equation for it was, x squared plus y squared is equal to 1. That any point on that circle with a radius 1 would have to satisfy this equation. That's what I'm going to use. Now that I have my value for x, I'm going to use that equation to find my value for y. You could also think about this as coming from our formula for r. Remember that r was square root of x squared plus y squared, or in other words, r squared is x squared plus y squared. And since we're on a unit circle, r is 1, and that's another way of thinking about where that equation is coming from. Anyhow, so let's find our value for y. We know that x squared plus y squared is equal to 1, and y is supposed to be, x is supposed to be negative 3/5. And so we can find out without too much difficulty that y squared is equal to 16/25. So now the next thing that we need to think about here is when we're looking at what y is, we know that we're going to take a square root, but the question is it the positive square root of 16/25? Is it the negative square root of 16/25? Which is it? And for that, we need to think back to the fact that we're in quadrant 3. And if our angle is in quadrant 3, you know that the x-coordinate for that point will be negative, and also the y-coordinate for that point will be negative. So when I'm thinking about am I taking the positive root or the negative root, I know I must be taking the negative square root of 16/25, and that's because we are in quadrant 3. So that means that y is just negative 4/5. And now that I've got x and y, we are good to go to define all of our 6 trig functions, or to give their values. Sine of theta is just the y value. Cos of theta is just the x value. And tangent is the y value divided by the x value. Negative 4/5 divided by negative 3/5, which simplifies to give me 4/3. And for my other 3 trig functions, those are just reciprocals. So since sine is negative 4/5, then cosecant of theta is negative 5/4. Since cosine is negative 3/5, then secant of theta is negative 5/3. And since tangent is 4/3, then cotangent of theta should be 3/4.